Hello, welcome to this MOOC, Massive Open Online Course on the principles of CDMA, MIMO and OFDM wireless communication systems. So this is a massive open online course on the principles of CDMA, MIMO and OFDM wireless communication systems, and these, that is CDMA, MIMO and OFDM technologies, which we are going to talk about extensively in this course, these form the basis for the current 3G third generation and fourth generation wireless communication systems. So these form the basis So these are the basic technologies for 3G, that is the third generation and fourth generation wireless communication systems, and in fact these are also going to be extensively used in the upcoming fifth generation wireless communication systems. So to better understand the impact of these technologies, that is CDMA, MIMO and OFDM technologies, let us briefly look at the evolution of the wireless communication systems, that is how have the wireless communication systems and standards evolved over the different generations of wireless technologies, right? So to begin with, we have, so let us talk about the evolution of wireless let us talk about the evolution of wireless technologies. So we have, let us start with our basic second generation wireless technologies. So we have 2G, where 2G represents second generation, and 2G, one of the fundamental technologies of 2G is GSM. I am going to explain these acronyms shortly, which has a data rate. This is the technology or standard, and this is the approximate data rate. 2G has a data rate of approximately 10 kilobits per second per user. And another competing 2G standard, or another standard in second generation, was CDMA, which also had a basic 10 kilobit per second kind of a data rate. And moving on slightly ahead, 2G evolved into 2.5D, that is 2.5 generation wireless communication. In 2.5G, we have technologies such as GPRS, which enabled a data rate of around 50 kilobits per second, and also another 2.5G or sometimes also called 2.75G standard is Edge, which had a slightly higher data rate of around approximately 200 kilobits per second. So these are the basic 2G technologies, which you can see these are the beginnings of the digital wireless communication revolution, and these were around, if you are looking at the time scale, these are around approximately around the 1990s. These were deployed in various countries and across several continents, and approximately starting with the early 1990s and evolved fully by the late 1990s. And to explain these acronyms, we are going to look at several acronyms as we progress through this course. So GSM, which is the most popular wireless communication standard, this stands for the Global System for mobile communications. CDMA stands for Code Division for Multiple Access. GPRS stands for the General Packet Radio Service, and EDGE, which is a 2.5G standard, stands for Enhanced Data for GSM evolutions. These are the various standards, that is GSM, which is the global system for mobile. We have CDMA, that is Code Division for Multiple Access, GPRS, which is a General Packet Radio Service, and EDGE, which stands for Enhanced Data for GSM evolution. And this is the basic scenario of the 2G wireless setting. And moving on, these 2G wireless communication systems evolved into the third generation wireless communication system. So 2G gave way to 3G wireless, or the third generation wireless communication systems. So we have 3G, or the third generation wireless communication systems, and I am going to make a small list of these third generation wireless communication systems, similar to what we made for the 2G scenario. And we have 3G. One of the fundamental standards for 3G is WCDMA, or UMTS, which has a data rate of approximately 384 kilobits per second. So this is our, again, technology, and this is the approximate data rate, the data rate capability. I have also 3G. Another standard is CDMA 2000, which has a data rate of, again, approximately 384 kilobits per second. And this evolved into a 3.5G standard, that is HSDPA / HSUPA, which has a data rate capability of around 5 to 30 megabit per second. And another 3.5G standard, which was 1X EVDO revision A, B, C, which has a data rate around 5 to 30 megabit per second. And if you look at the timeline for 3G, these were around the early 2000s and fully evolved and were deployed in various countries around the late 2000s, that is, spanned the decade from 2000 to 2010. So if you look at 3G, the lifetime of 3G was around the 2000s. There's a 2000 to 2010, and of course currently being also deployed in several countries. And let us again, so you can see that these have a data rates from several hundreds of kilobits per second to a couple of tens of megabits per second. And to look at, again, let us look at the different acronyms. We've already seen CDMA stands for Code Division for Multiple Access, and WCDMA, which is closely related to CDMA, stands for Wideband CDMA, or Wideband Code Division for Multiple Access. UMTS is the universal is the Universal Mobile Telecommunication Standard. HSDPA is the high speed downlink packet access. And our EVDO stands for evolution data optimized. EVDO stands for evolution data optimized. All right, so we have these different standards: WCDMA, which is wideband CDMA; UMTS, which is the Universal Mobile Telecommunication Standard; HSDPA, that is the high speed downlink packet access, and the corresponding uplink standard is HSUPA, which is the high speed uplink packet access, and we have EVDO, which is evolution data optimized. And as we said, these have data rates spanned roughly the decade of the 2000s and had data rates around hundreds of kilobits per second to a couple of tens of megabits per second. And these further gave way to the fourth generation of wireless communication system. So this is 4G, or the fourth generation of what is also known as the fourth generation of wireless communication standards. And in this, there are mainly two 4G standards. One is 4G is LTE, which has again 100 to 200 megabits per second, and another 4G standard is WiMAX, which has again a data rate of about 100 megabits per second. And also we have some other standards such as LTE Advanced, which have a significantly higher data rate of about half a gigabit per second to 1 gigabit per second. And LTE again is roughly spans the 2010s, the decade of 2010s, that is roughly starting from 2010 to also currently in progress, and its life cycle is expected to be around till around the year 2020, when 5G is supposed to progressively take over. That is the fifth generation. And LTE stands for long-term evolution, and WiMAX stands for worldwide, stands for the worldwide interoperability for microwave access. So we have two dominant standards or technologies, that is LTE and WiMAX. All right, so these are competing 4G wireless technologies. And therefore, let us now look at what are the different capabilities, or what are the different applications that are possible, or what are how has the application scenario evolved across these different generations of wireless communication systems. So let us briefly look at the applications, or the evolution of the applications So let us look at how the various applications have evolved in this 3G from the second generation to the third generation to the fourth generation. So if I have look at 2G, 2.5G systems, as I said, I have a data rate which is around 10 to 100 kilobits per second roughly, and therefore, this enables your voice telephone calls plus basic data access, that is your basic internet access. So, this is the approximate. So, the first column is the technology or the generation of the technology, the second column is the data rate, the third column is the applications that are possible, and we are saying in 2G and 2.5G, which has a data rate around 10 to 100 kilobits per second, some voice and basic data access are possible. In 3G and 3.5G systems, we have data rates approximately 300 kilobits per second to approximately 30 megabit per second, and this enables a whole many more applications than what were possible in 2G and 2.5G systems, such as voice, high speed data access plus video calling and so on. And further, this has led to 4G, and in 4G we have data rates in excess of 100 megabit per second, and this has led to a plethora of applications such as online gaming, which requires fast transmission of high definition video between multiple players who are participating in this gaming application. Also high definition video conferencing, multi-party video conferencing, also HDTV, transmission of high definition TV content. So online gaming, video conferencing, high definition, multi-party video conferencing, HDTV, all these are applications that are made possible by the fourth generation of wireless communications systems. So if you look at these different generations of wireless communication systems, as you look at the behavior across these different generations, you can see that as the generations are evolving, the data rate is progressively evolving. It is easy to see that. So, increase as the data rate across the generations, the data rate is progressively increasing. Also the reliability which information can be transmitted is progressively increasing, because when we talk about the transmission of video content such as is required in for instance gaming or video calling, that requires a significant amount of reliability, not just data rate, but an assurance on the quality with which the data or the bits are transmitted across the channel. So, there is an increase in data rate. At the same time, there is also an increase in the reliability or the quality of service of transmission of this information across the channel. So, data rate increases. Also, there is importantly, there is an increase in the reliability. Increase in reliability through these different generations, and this data rate increase and this increase in reliability is fundamentally possible because of various technologies or various radical revolutionary technologies in the area of wireless communication. So, this is made possible by fundamentally three different technologies. One is MIMO, the other is OFDM, and CDMA. So, these are the three technologies which make this phenomenal increase in data rate and reliability across the different wireless different generations of wireless communication systems possible. Let me explain this. MIMO, and these are the technologies which we are going to talk about in detail in this course, stands for multiple input, multiple output. So, MIMO stands for multiple input, multiple output wireless technology. CDMA, as we have already seen, stands for code division for multiple access, and another important technology which is OFDM, stands for orthogonal frequency division multiplexing. So, I have three fundamental technologies: MIMO, CDMA and OFDM, and these technologies have led to an increase in the data rate and reliability, a significant increase in the data rate and reliability across the various generations of wireless communication systems as we go from 2G to 3G. 3G is dominated by CDMA and also multiple antenna systems, multiple input, multiple output systems, and of course 4G makes extensive use of MIMO technology and also OFDM, which is the orthogonal frequency division multiplexing. So, these have totally changed the landscape of the wireless communication systems and tremendously increased both their capabilities and their performance, making them what they are today in terms of making possible a wide array of applications in both wireless cellular networks and also wireless LAN applications. So, we will be studying in this course, we will primarily be focusing on these three technologies, that is MIMO, CDMA and OFDM. We will be studying various aspects of these technologies such as the motivation. First, what is the motivation? So, we will be studying various aspects such as the motivation, the details of these schemes, how are these, and also the performance. Which is the most important thing, that is how to analyze the performance, that is what is the motivation for each of these, what are the details, how was each of these technologies implemented, and an idea about the performance, how can one get an idea of the different possible schemes, what is the performance, by how much and how far do they enhance the performance. So, this is what this course is about. We are going to focus on these aspects of MIMO, OFDM and CDMA technologies, which form the backbone for the evolution of current wireless communication systems. So, we will stop this module here. Thank you very much.